Hello and welcome to another session of our Data for SaaS playlist, which I hope you've been enjoying so far. My name is Grant and I'm a specialist solutions architect here at AWS. In today's session, we're going to explore tenant management and telemetry within a software as a service or SaaS implementation. This is the agenda for today, and in this session, we're going to cover the following topics. We're going to start with a quick recap of some tenant fundamentals, some concepts, some terminology you may have come across. We're going to talk about why being able to identify and capture tenant by tenant performance metrics are so important and the advantages that it can give to your SaaS business. And then we're going to walk through a AWS blog that outlines an example solution for capturing these metrics and presenting them in a downstream dashboard. Full details of the blog and the technology will be included at the end of this presentation. To start with, let's just recap on some key SaaS terminology and concepts that I hope you've already become familiar with throughout our earlier sessions. In terms of SaaS design principles, your design needs to be secure, efficient, and scalable. There is no one-size-fits-all in terms of SaaS architecture. You need to isolate your tenants. It's not optional. It's very important from both a data privacy, a performance, and a data security point of view. You want to have an efficient infrastructure where you're not resourcing waste, and you want to have your cost model that rises if need be with the increase in your tenant volume. You don't want to waste money and resources unnecessarily. You want to scale as the success of your SaaS business grows. We talk about three main deployment models. We talk about the S.C.A.L.E model, which is where the data for your tenant is in its own separate, isolated ecosystem. It's fully isolated from other tenants and therefore is ring-fenced from resource impact from other tenants as well. Conversely, we have the pool model, which is where data for all tenants is stored in a common set of tables within a single schema, and you have to use concepts such as row level security to isolate the tenant data at a table or row by row basis. Conversely, between the silo and the pool, we have the bridge model, where you do have some isolation, where each tenant is in a separate database within a single cluster or separate schemas within a single database. And it does allow for some degree of variation and separation for each tenant. You can, of course, start out with the simplest or easiest model, which is a pool model. And then as your tenant consumption grows and your popularity increases, then you can carve out separate databases for those tenants into a silo or a hybrid tenancy model downstream if need be. We're then going to reinforce our common theme throughout these YouTube sessions around the acronym SC.A.L.E, which stands for Scalability, Consistency, Availability, Latency and Evolution. The theme of today's topic is going to be based around latency. And the definition of latency from our point of view is, are your tenants happy in terms of performance? How do you know they're happy? If they're not happy, what can you do about it? And some of the key drivers around this is the tenant aware metrics and insights that we're going to talk about today, mitigation of noisy neighbors scenario, we'll talk about that, and being able to vary the performance in a tenant by tenant basis if need be. So what is a noisy neighbor? Typically, it's where the user of your SaaS system can place a load on the system resources that can have an adverse or negative impact on other users of the system. There's no ring fencing, there's no filtering of consumption. It's just a particular user causes a big influx of requests. It could be compute, it could be storage, it could be I/O, any of your resources, and that then degrades the general performance of your other tenants within your system. So If we now move on to performance efficiency and start to define what it means and how it's of importance to a SaaS implementation. So why should we care about having metrics of our systems, and why should we care about gathering those at a tenant by tenant basis? And we can we can distill this down to a single statement, which is if you know your tenant consumption needs, you understand how your service is responding to them, which means you can accommodate distinct tenant needs and optimize your application performance. And once you instrument your SaaS solution, then you can start to look at how these metrics can be used to create better alignment between your costs and the activity. In the graphic on the screen, you can see a couple of lines. The red line is slightly above the blue line at all times. The red line indicates the your cost of delivering your SaaS solution. Tenant consumption is just below the line. So in this example, this is saying that as the tenant consumption goes up and down or varies throughout the day, um, the the scale and size of your implementation and it is just above the blue line, and therefore you are able to satisfy your tenants without having to over provision resources or worst case under provision and have issues. It means that you're optimizing your cost model for your tenant consumption at all times. We touched earlier about noisy neighbors and the potential for problems this can introduce. So how do we mitigate against them? There's a few different things we can do. If you've got a basic tier tenant versus a more advanced or gold, silver, bronze type scenario, your basic tier tenants could operate under lower limits or lower capacity than your premium tenants. This could be a way to provide value add or service add to your customers. It could be to say, hey, if you want to run X workload on my system, then therefore you'd have to pay an uplift in cost to get access to the greater capacity. You can introduce the concept of scaling policies that can help your service to absorb some of the load, but the scaling may not necessarily react fast enough to prevent a degradation in performance. Another option is to impose limits, potentially by your tenant tier, and also optional throttling to control the load placed on the system. One way of doing this within Amazon Web Services is to use our Amazon API Gateway usage plans, which can be used to throttle usage at an API level and introduce quota management because the usage plans can be assigned to distinct tenants and configured to control the rate of access to a given resource. So why do metrics matter and why should we care about them? To start off with, we'll touch on the question of why metrics matter to your business. What they do is they empower your business and your teams to gather insight into how the tenants are using and placing load on your system. And that can play a vital role in shaping the technical and strategic direction for your SaaS offering. From the business side, the metrics can help to determine which features are being used by the tenants and the tenant tiers, and they can also provide rapid insight or feedback into the impact and adoption of new features. If your development team has just introduced feature X, you want to know that the tenants are using it and they're consuming it um, to a certain degree to know whether your feature that you introduced delivers on what your customers want and therefore is making them more sticky within your ecosystem. And that can help to influence the overall product strategy and business priorities of your SaaS implementation. Conversely, why do metrics matter to your operations or infrastructure team? What they mean from a keeping the lights on is to it enables you to see how your tenants are imposing load on your system and how your system is responding to the continually evolving nature of a multi-tenant workload. So your operations team can use the data to assess the overall health of your system, to identify any bottlenecks that may be created by individual tenants, a- and to have the data and the data points to look into any performance issues or any scalability concerns around this particular set of functionality isn't performing as it should. Perhaps we need to improve it, re-architect it, revamp it so it scales better under load. So once you have the metrics infrastructure in place, you need to look at how to introduce and build the instrumentation into your SaaS application to capture and publish the metrics. In the example on the screen, we're going to walk through a simple flow that captures and publishes some metrics. So in point one, we're capturing the execution time by using this execution time metric instance class. In step two, we call it an instance of the publish metric event to publish the metric. Step three, we're passing across a JSON web token or JWT token to the metric publisher because the JWT token has the user and tenant information embedded within it so that we can tell at a API call or an event call who actually called it, where they came from, and what level of access they could have. And then finally, in step four, we have an optional hash map or entry where we can pass across any additional information um, in a set of key value data pairs to the actual metric implementation. So building on the code snippet in the previous slide, this is a simple example of an application that uses DynamoDB, which is one of our NoSQL database offerings, to manage its data. In this particular example, we're relying on a data access layer or DAL to manage access to the database. So from the user interface, it publishes a metric to indicate that a update product page was called by the user, and therefore the page view count is increased by 1. That then flows through the application layer, through the data access layer, to then update a product within the DynamoDB table, which then returns back a execution time of 400 milliseconds. So in essence, we're storing two entries, the fact that the update products was called and the fact that the call took 400 milliseconds to return. And that goes through the metrics manager into the metrics infrastructure and then captured for downstream history and analysis. Because there are many different types of metrics in terms of um, the levels that we collect them at, the granularity, the services that are called, we want a generic but flexible way to capture these metrics from all this wide and varied set of data providers. Now, what we have on the screen here is a generic example of how you could structure a metric event, and we're going to drill into each of these components one by one to give you an overview of the sort of information that can be captured and should be captured. We'll start with the type attribute, and this can be used to categorize the metrics down to such levels as application, business KPIs, infrastructure, whatever sort of high level sort of categorization or grouping you want to introduce. Then we move on to the workload and context. And this is where you can go down at a more granular level and use the workload field to capture such things as the application name, which could be product application. And the context for that could be um, drilling down to the workload further, such as the product service or catalog service within the product application. Then we have the idea of the tenant. So this is this is who the tenant is, what their name is, what level of access or tier they're on, because that is invaluable for the resource consumption and to show if they've got any sort of quota limits or um, availability access limits that are in place on a tenant by tenant basis. And by storing the tenant context and the fact that we can associate the tenant to the metrics, this enables us to build richer visualizations through, through the lens of individual tenants in our downstream business intelligence dashboarding. Then we finally get into the metric, which is the actual data element of what we're capturing. So, in essence, what it is, the measurement unit, and the numerical value of the metric that we're capturing. It is, of course, important to have a consistent unit value for the captured metrics, so you don't have to do any on-the-fly conversions from megabytes to gigabytes to megabits per second to kilobits per second, for instance. You can also send additional information in the metadata, um, such as the resourcing information, so who the user was, what resource they consumed, because that can also be valuable to help apportion the cost of your SaaS implementation to the downstream or back end AWS service costs. Finally, you want to capture all this valuable metric data into a data store that can be easily interrogated and analyzed. So the generic format you saw in the previous slide, in this example, is stored in a relational table within Amazon Redshift, which is our petabyte scale data warehousing product based on Postgres. With the example here on the right, we can see that we stored a data transfer operation of 810 megabytes um, for tenant one, who's on the standard tier, and it was done by a user four um, using the load balancer resource. And this was for, from a context point of view, the photo upload service within the photo application. And this is what the metric data tables look like in Redshift, where we can see the typical data flow that gets stored within each row. And this raw data being stored in a SQL table can be interrogated via SQL directly or published to a BI dashboarding tool. And it can be reported on for billing purposes. It can be aggregated for capacity planning or even visualized in a tool such as Amazon QuickSight. So how would we then go about building the metric infrastructure that you've seen on the previous slides? So we'll get into a bit of an architecture walkthrough of the blog that I mentioned in the very early part of this presentation. On the left side of the diagram, you'll see that tenants are consuming a SaaS application, and as they consume various features, service 1, 2, and 3, they all have their usage captured by the metrics manager and the publication of a metrics event. That then flows through into a set of common services within AWS, in this case, Amazon Kinesis Data Firehose, which provides a scalable and serverless way of ingesting the metric data. Your application can publish these events directly to Firehose, or it can call them via the metrics manager that we've got on the screen there as part of a solution to simplify the effort involved. Once the data is pushed to the Kinesis Data Firehose, it's then streamed across to Amazon Redshift. Now, Kinesis does this via its direct integration with Redshift, but it first also streams the data to an intermediate S3 bucket. The data is then copied from S3 back into the metrics table within Redshift. And the last piece of the puzzle is Amazon QuickSight, which is our GUI-based business intelligence and reporting dashboard, which sits on top of your Redshift metrics data and allows you to build some custom views of tenant trends and activities. In the next few slides, we're going to look at some example GUI dashboards for a tenant application that are all based around tenant consumption and usage of our simple storage service or S3 consumption. So this is how some of the dashboarding can look based on the data in Redshift that we saw previously. So QuickSight, as I mentioned, it's a serverless business intelligence offering. You can build visualizations, ad hoc analysis, and get insights. So this dashboard is showing S3 storage used by workload and feature. So workload and feature being software components within your application. You can see the usage, and you can see based on your components what's using what amount of storage, what's contributing to your S3 storage costs on a month-by-month basis, and perhaps could be used to optimize or reduce your AWS costing if your S3 storage bill starts to increase and you're not sure which particular software component is causing the increase in cost to be accrued. We can then get into storage used again in S3 by tenant and by tier. So we can see the idea of a basic tenant, basic standard premium tenant. On the right side, we can see tenant 1, 2, 3, 4, 5. And this could be used to help apportion the storage cost or allocate the costs by a tenant and tenant tier. So perhaps the higher tenant tiers could have an amount of defined free storage as part of their subscription cost. And this could be used to determine what level of free storage should be allocated to these premium tenants based on their existing consumption. You may say that 40%, 60% of their consumption is free. Anything over and above that is then pay per use, charged accordingly going forward. Then we can get into S3 storage used by date and by tier. So this can help with any future capacity planning or historical resource consumption. You can see how your storage patterns can change over time and based on the different tenant tiers. So who's using the storage, what storage usage has increased over time, and what has reduced over time as well. Finally, we can look at the top X features and modules by tenant. So this could be used to help reduce the cost of servicing our tenants. If we discover features that aren't being used at all, and we know that if we obsolete them, decommission them, remove them, that could simplify our code base. It could perhaps reduce our consumption. And conversely, it can make our tenants more sticky by looking at areas where we can enhance our existing functionality that's already proving popular to say we've got a great usage of feature X. If we introduce feature X.1, X.2, X.3, then does that mean that our tenants are going to use more of our services because they're interested in what we deliver currently? Finally, here's some resource links for you to take away and explore around our Data for SaaS and S.C.A.L.E initiative, including links to our GitHub code repository, some AWS documentation around the gateway throttling plans that I mentioned earlier. And finally, in yellow, the actual blog I'm referring to here about capturing and visualizing multi-tenant metrics inside a SaaS application. We've got the blog, we've got the code samples that are produced, what I've shown you on the slides. We look forward to seeing you in our future sessions. We certainly value your feedback in terms of content and any future subject areas that you want us to explore in subsequent sessions. So with this, thanks a lot for your time, and I'd love to see you again in another session.